We're at the site now. This is the E3 site. It's Eel Creek. As you can see, there's the Highway 101 culvert over to my left, and the chute is down behind me, and that's where we're going to place the continuous temperature probe today. Wanted to say that I viewed the video that I did last time when we were doing our setup. Sorry about getting too close. Realized that I didn't need to be pulling that up. It just made everything out of focus for you. Sorry about that. Kind of learning as we go here, but we'll try to do a little bit better. This is the form I'm going to be using today. Okay, not getting too close. The reason we're going to use this form is we record the time where we deploy it, or when we deploy it, and where, and we also come out once every 2 to 4 weeks and do a check. When we're doing the check, we put the digital thermometer down next to the probe and record the temperature. Since we're not going to pull the probe out of the field and hook it up to the computer, we won't know whether it is actually, the two are synced up until we pull the probe out in October. So it's just sort of a recording. We just write them all down, and then at the end, when we're all done, we compare it to see if it works. So today what we're going to do is actually put the probe in the field. I'm going to use a piece of rebar to pound into the ground in the stream, and then attach the probe using cable ties. Basically what we'll do is just cable tie one through the little hole where the temperature sensor is, and then another one or two around here. Depending upon the situation, you can do this ahead of time and then just pound the whole thing into the ground, or you can pound the stake in first and then go down and clip it on afterwards. That's probably slightly better choice if you can, because the pounding might, the shocks might hurt the probe. But if you're in deep water, you don't really have a choice a lot of times, because you can only reach down so far. I'm not sure how deep the place is that we're going to put it in today, so I brought a couple of different sizes of rebar with me. Also brought a small, they call it a 3-pounder. It's a small sledgehammer, and basically it just allows you to pound it in, but it's not so big that if you're hiking somewhere you can't take it with you. I did put a lanyard on the end of it in case I drop it. Kind of saves your equipment. I think that's it. I'm going to show you a little bit closer up of the place I'm going to put it. In this particular case is a little different. I'm going to put it into the rapids, which is kind of unusual, but I am just looking here for the lamprey spawning temperature, and they're spawning right above where I'm going to put it, so I thought that was the best place to put it and enable us to hide it. Once again, we don't want it to be visible to the public, so if I put it kind of within the rapids, they won't be able to see the probe or the stake. So with that, I'll cut here and then show you a little bit about the place I'm going to put it, but probably not the deployment. That's just basically me walking out and pounding this in, so I'm sure you can figure that out. Okay, so this is the Highway 101 culvert. We're calling it E3 for Eel Creek, number 3 culvert. You can see traffic going up on the highway above it. This has had passage enhancements done to it. They put interior baffles into the culvert. You can kind of, maybe you can't, but maybe. There's concrete baffles that go across the whole area inside the culvert. They used to be full baffles because they were meant for salmon. The reason you put a baffle inside a culvert is to allow the salmon to jump over them and then kind of dive down and hide behind the next baffle so that they can rest as they go through the culvert. Since the culverts narrow the stream, it causes the flow to increase, and that can be a passage barrier to salmon trying to migrate up when they're coming up to spawn. The problem with those interior baffles for the lamprey was they couldn't get over those concrete barriers when the water was low. So they ended up going through and cutting the middle section out of the barrier, and that allowed for the lamprey to swim through the middle, and at the same time the edges remained in place so they could kind of go to the edge and hide and kind of catch their breath like the salmon do. So this is a jump pool here in front of it. It's a pool that they put in here just to make sure that the salmon would have enough depth to be able to get the necessary jump to get over the interior baffles that we were just talking about. It comes down, and this is kind of the rim of the pool here, and then you can see it just sort of goes down on to the stream below. Remember, this is a dunal system, so this is just a stream that goes through a sand dune. So all this gravel you're seeing here is all artificial. It's all been put in as part of the culvert project originally. So the lamprey don't have a lot of natural spawning habitat, and so they use this area here for their spawning grounds. It's really terrible in terms of the quality of rock that's here, but they're just kind of using what they have, and so that's what they do. I'm going to put the probe right here in these rapids over here, and hopefully I'll be able to pound it in far enough where we won't be able to see it in the end. All right, I'm at it. Okay, this is what the final look is. I'm left about that much to pound into the ground. Got it all zip tied on, and have hopefully enough that I can pound this in and it'll still stay underwater and out of sight. Okay, I got the probe in and ran into a little problem, which is kind of normal for field work. The place that I put the stake out in the rocks was kind of between two rocks. Is where I was able to get the best purchase when I was pounding it in, and that ended up being much deeper than I expected. So I had to end up taking the temperature probe off, pounding the stake in, and then putting it on manually. Depending upon the time of year, that can get kind of cold on your hands, so you can wear big tall rubber gloves if you want. It keeps your hands from going numb and allows you to keep your dexterity. But I was able to do this. We're about 51 degrees out there, so it wasn't too bad. So what we do with the data now is to record it on our sheet, and I think you have this sheet. And if you look closely where it says reference thermometer, trying not to get too close here, but I think you can probably read it. Reference thermometer result, so that's the one we're writing down, is 51.4. And then over on the right, under comments, I put deployed and the time that we deployed it. And there's the reading I got from my digital thermometer. Notice that it says hold. It kind of flashes on to the word hold. These digital thermometers can hold one temperature in its memory, just so you can use it like I did today. I put the the digital thermometer on hold when I was in the stream, and then wrote the data when I got back here, so I didn't have so many things to juggle. It's important that you check this thermometer every 2 to 4 weeks, and basically just come out to the site, you put your digital thermometer in and take a reading. Once again, we can't compare that reading to see if it's accurate until the end of the season, but at least we have that data kind of stored, and we'll be able to tell later what happened. If you remember right, we programmed the thermometer to go on at the top of the hour. Remember that this thermometer is only reading once every hour. The ones we were doing in the lab allowed us to do it every minute because we were doing taking those readings in the ice bath and stuff. This only goes off once an hour, so you have to be at the site at the top of the hour or whenever you programmed it for in order to get that comparison reading. It's important to plan your times when you're going to start your probe, so that you can get from site to site if you have more than one probe. If you do everything on the top of the hour, then it forces you to wait till the top of the next hour after you've done the first one. So if it's only 10 minutes up the stream, then that could be a real issue, especially if you got like 10 of them. If you waited an hour on each one, then obviously it'd take you 10 hours to do it. So I think it's important to plan that ahead, so that you know more or less the travel time between one and the other. Give yourself an extra 10 minutes or something, but kind of get that in your planning when you're programming your probes in the first place. And that just gives you a little bit of efficiency in the future when you're out in the field trying to run these tests. Also talked about programming them every half hour. That's another advantage of doing the half-hour intervals instead of the hour intervals. It gives you a little more flexibility. You know that you'll never have to wait more than a half an hour to take your comparison reading. But you do have twice as much data to monkey around with. Okay, I think we're done with this lab. Thanks for hanging in there with me. I know these videos are long and it takes a while to get through them. But usually on the labs we're taking like 3 hours to run these labs, so I guess we're cutting the time down some. We'll see you next time, and stay safe. Bye.